Now, before I get started, I just want to apologize for my raspy voice. I am dealing with a little bit of a chest cold. Now, in my last video, I presented some of my reasons for having serious doubts about neo-Darwinian theory. It seems, though, that some aspects of what I presented were not clear to some, so I wanted to make this video to clarify some of the points that I was trying to drive at. My main goal is not for people to agree with my conclusions, but rather to be sure that they understand the arguments that I am making, as it was clear from many of the responses that I received that people did not really grasp what I was actually trying to convey. So let's delve into this. First, my goal is actually pretty modest. It is just to show that rhetoric from pundits like Dawkins represent fanatical dogmatism, not science. And in fact, there are very credible and reasonable reasons to question the neo-Darwinian models. Essentially, everyone agrees that it is the information in the DNA code that controls the form and function of biology. But the question evolutionary theory must answer is, how did it arise? How did we get this information? The classic textbook answer is that random mutations or changes happen in the code, and then natural selection over time eliminates the harmful changes, thus only leaving us with beneficial changes which build up over long periods of time. It sounds good, but there are two big problems that are best illustrated by an example that shows how random mutations and selection actually function. So let's set up this example. First, we have to keep in mind that in order to have an organism, you need functional information, because these functions are what allow an organism to survive. So in biology, functional information are sequences that aid in the survival or fitness of an organism. In our example, functional information will be sequences that communicate in the English language. So for instance, we can see that the word strong is 100% functional. And we can see that if we scramble those same letters into a random sequence, they are 0% functional. Next, essentially every organism faces selection pressures. In biology, these are factors that lead to the elimination of the least fit in a population. For our example, we will be assuming that these selection pressures only allow for 50% of the population to survive until reproduction due to resource shortages. Also, we will say that if their total functionality falls below 25%, they won't have enough functionality to be able to survive to reproduce. Now let's look at mutations, which basically are just changes. There are only three types of mutations. First is beneficial mutations. These are mutations which increase function or fitness, which we will denote by the letter F. Harmful mutations are those which decrease fitness, and neutral mutations, we will say, are those which have no effect on fitness. So with that, let's take a look at what actually happens as organisms mutate and reproduce over time. All right, so in this video, we're going to look specifically at how genetics change over time and how selection and mutation and basically functionality or fitness work. So we'll just start off with Bob here, okay? Bob's genome looks like this, okay? We're just obviously simplifying this using English letters or English words. So Bob's genetic code is the big, strong hands, okay? And all of those words are functional in communication in English. Therefore, his functionality of his code is 100%. Bob has a couple of kids who are going to inherit this code, but there's going to be mutations potentially. Well, his first son, Joe, doesn't have any mutations whatsoever. There's no change to his genetic code. Still functionally 100%. But his son Larry has one beneficial change. Check that out. He's evolving. He's getting better. So this son has an extra word. It's man, which makes him more functional. His code has, it's better adapted at surviving because it has more functional information, and functional information is that which aids in survival. So he is more fit. Larry is more fit than Joe. His fitness score, his fitness percentage is 125%, we're going to say, because he has this extra word. And so therefore, there's only enough resources, according to this example, for half of the population to survive. So that means Joe is dead. So Joe doesn't get to reproduce, but Larry does, because he is the most fit. So Larry then goes on to have children. Well, his children, they get some mutations that happen, okay? His son Dan has 3 harmful changes that happen to his genome. The word big becomes be, which isn't an English word. Strong becomes strewn, which is not an English word. I don't know if strewn about the floor is a word, but we're going to pretend it isn't. Hands, it works, but he lost the entire word hand, or man. So in this, there's only 2 functional words out of the 4. That's 50%. That's not good. Well, Jack, he had 2 harmful mutations. The stayed good. Big stayed good. Strong also became strewn on him. Hands became hack, but he kept man. So in this instance, the percentage of these words that are functional is 60%. So in the competition for survival, Dan is gone. His genome is gone forever, but Jack's is now passed on. So you might be noticing now what's going on here. All of these mutations were passed on, and this code is a lot less functional than in previous generations. And it can't go back unless you get a bunch of beneficial mutations down the road. So let's keep going. Well, Jack here has Eric and Dean. Well, Eric inherited 1 harmful mutation. Dean inherited 1 beneficial mutation, which is great. That means the functionality is going to go up. But he also inherited a neutral mutation, or a neutral change, okay? If we look at that, what it is that he inherited okay, that was good. Big came through good. Strewn, that was the beneficial mutation. It became strong again. Cool. So that's an increase in function. But hack became hab. Okay, hack became hab. That doesn't really change the functional percentage because it was already non-functional, and now it's, still non-functional. So that's what we call that neutral change. And then man and man. So his functionality or fitness is at 80%. He survives. Good. So we had some positive evolution here. The code got better. He became more fit. Maybe we're going to reverse this trend and go back to 125% or 300% over time, or 1,000,000% over billions of years. Well, as you can see, okay, the next generation has 3 harmful changes, 1 neutral change, 3 harmful changes, 1. Anyway, you can look at this. You can go through these each individually and look at them. But as you'll see here, Tom's, his genome falls apart here, so he dies. Dick survives. He still had functional 50%, but then, it's still going down. We're getting too many of these stupid, harmful changes to the genome, and now you're getting down to where Mike and Steve, eventually you get to the point that it's so mutated, it's so jumbled and scrambled over time that what you're left with is not enough functionality for either of them to survive, and then you get extinction. Okay? So it's pretty obvious here what matters. What matters is the ratio of harmful changes. Now, not all. Some of them are selected away. Like these ones from Dan, they're gone. Don't worry about them. But we have to look at the ratios of the ones that are passed on from each of the surviving generations. How many are getting passed on over time? The ratios are what matter here. So when I took all the ratios of these, there were 4 beneficial change, 15 harmful changes, and 2 neutral changes. If you looked at this entire little, generation by generation map here, that means 26% of the changes in this line were functional changes. They actually increased the information. This is ridiculously generous, okay? In the real world, according to the research, beneficial changes, even from those who are, pretty avid Darwinists, they're not going to say it's, you'd be hard-pressed to find people to say it's higher than 1 or 2% even. The vast majority of people say it's like, 0.0001% or something like that, or maybe 1%, just depends. But the bottom line is it's nowhere near a majority, and it would need to be a majority in order for this to go in the opposite direction, away from the decreases. So this presents a pretty major problem It shows that not evolution, which would mean the F-score is going up and the code is getting better and more complex over time and longer, but rather that the code is being scrambled and falling apart. This is not evolution, okay? Because evolution selects for again, not the good and bad mutations. It doesn't act at this level. It doesn't act here on the changes. It selects the best of the population of those who live within a given generation, and every generation inherits new mutations from the last that are untouched by natural selection. So based on what we just saw, we can deduce a few key facts that act as the basis for my argument. The first fact is just that non-functional information, also known as random information, does not produce a living thing. The next fact is that natural selection selects the most fit organisms, not the best individual or most fit mutations themselves. Therefore, mutations of all types can and are passed on from one generation to the next. The third fact is that the mean fitness of a population will fall over time if the ratio of mutations that are passed on from one generation to the next are mostly harmful. And lastly, the fact just is that the vast majority of mutations that are passed on are indeed harmful. So, given these facts in a population, on average, each generation will inherit a slightly less functional genome than the previous generation. This is not the evolution you were taught in school. So, let's look again at the neo-Darwinian model. It's pretty clear to see that random mutations do happen, but we can now see that natural selection has almost no power because it selects organisms, not individual mutations. So the genome simply arose through random mutations alone? This makes no sense. So yeah, there are perfectly legitimate reasons to doubt neo-Darwinian theory. Also, if you doubt any of these facts that I've presented that act as the foundation of my argument, you can find below the research that supports each of the facts that I've presented. However, with that said, I do not claim that the writers of those papers all agree with my conclusion, but I'm not making an argument based on authority. I am making an argument based on facts and logic, and their research does support the facts that I present. Therefore, if I'm missing facts or if the facts in this video are not correct, please let me know. I'm willing to be wrong, and I may be wrong. But I want to understand why I'm wrong. I already know that there are some really smart guys who disagree with my conclusion, but there are also some really smart scientists who agree with my conclusion as well. I'm trying to understand the facts so that I can come up with my own conclusion based on the facts to see who's right and who's wrong. Also, I will link below my responses to some common objections that I've got just so that you can be aware. I really do look forward to all of your feedback. Hey, if you enjoyed this video, give it a like and hit the subscribe button. Thanks for watching.